or thank you everybody for coming to my presentation. This is the first time I've ever presented on a water wastewater stream, and I thought that was kind of interesting, and I thought the introduction would be strange, all the architectural stuff in the building and the BIM, and here I am talking about water. But CH2M Hill, it's a unique company for me in that we've got so many different business group themes which we service to provide designs for. My title in CH2M Hill, besides everything he said, is Building Information Modeling Leader. And I perform that function within our water business group. So my goal and my mission is to bring the concepts of BIM and multidisciplinary work to all of our water projects. So I'm going to be talking about our Lakeview capacity expansion project that we did in our Toronto and Ottawa office in the regional municipality of Peel, City of Mississauga. The title, Applying BIM to Architecturally Showcase Treatment Innovation. There's some unique treatment aspects that I will discuss, and please don't ask me details about it because I can only talk about what is in this presentation with respect to the water. And there was a mission to actually make it an architectural showpiece, and we'll discuss that as we move forward. Very little bit about CH2M Hill. Everybody asks, what is CH2M Hill? Where did the name come from? So the name itself is an acronym, and the company is loaded with various acronyms, and I'll try not to use them when I speak. But we've got our founding fathers. The H2 is for Howland and Hayes, and that's where we get the CH2M Hill. Hill came on at the end. There was a discussion, should it be CH3M? And they decided not to do that, so we've got CH2M Hill. So BIM is our life, and it is a catchphrase, but it's more than that for us. It's a way to do work. It's how we conceptualize the project delivery. BIM encompasses not only just design, but how we apply the four-phase design process by the AIA to all of our projects, how we staff our projects, the type of technologies and innovations we actually apply throughout the course of setting up projects. And as technologies change, BIM changes, but it's always the same fundamental process. And it's the adaptation of that process which we continually focus on. Applying it was unique because we have 22,000 employees within our firm. We have 12 major business sectors. We have 200 offices worldwide. Everybody works differently. Every region works differently. Every engineer works differently. And depending on how long the engineer has been servicing our company, there is a mentality in a set way. So we had to step back and say, okay, BIM can do all of this. Everything, and I could go on and on for hours just about what BIM can do. But how do we get it to apply to our specific projects? So our initial process was, well, we've got to break it down to the fundamentals. Unfortunately, we still have to abide by contract documents. One day that will disappear, and I'm excited about dynamic views and the whole concept that one day I won't have to deliver a piece of paper, but we still have to do that for contractual and legal reasons. So we had to step back and say, if we do this model thing, and everybody would look, oh my God, what is this model thing? We have to say, this is how we'll get to our contract documents. And we had to spell out the process. We had to prove that it was cost efficient and actually that we were saving money and doing things more efficiently, and then thus all of the BIM stuff came afterwards. The Lakeview project came after the proving time, so the Toronto office accepted that 3D was the way to go, BIM was the way to go. You can get these schedules out of BIM, you can get quantities out of BIM. Wow, this is incredible. Let's apply it to our projects. Okay, Lakeview capacity expansion. Some constraints for this project was we had a very limited site. There's no pointer, I'll point. All right, you see at the end, oh, do you have one? Perfect, my savior. Thank you. Will do. The project encompasses this whole region. This rendering doesn't take into account the adjacent site. There's a little connector right here to an existing filter building that goes on and connects to a whole bunch of other things that are on the site. So we had nowhere to build this new plant. So we had to sandwich it within this constraint in the roadway. There's a little access point here, and the main building is this part. we had to maximize the space, and not only the space, we had to maximize the volume. We had to limit how much soil removal we could take out of the site. We had to limit how much materials we could put into the site. So the sustainable twist, that we didn't pursue LEED accreditation, but we did pursue LEED values and some points when developing this, some point concepts while developing the design. So the parameters, 400 megaliters a day has to flow in and out of this treatment plant. It was the first use technology for ozone, biological activated carbon, ultrafiltration, and ultraviolet cleansing. It was the largest UF membrane plant in the world at this time, which was 2004. Now we did a further design, the Twin Oaks Valley Water Treatment Plant in San Diego, which has, I believe, doubled the capacity of this plant right now. There was restricted space in the site, as I mentioned. We had a very quick delivery to complete this project. There was 800 drawings to be done and completed and tendered within a 6-month period. And in Toronto, we actually had this project sandwiched between 2 other major projects. So from a staffing and project delivery perspective, we just barely had that 6-month time to actually work on the project, or else we would have had to farm it out to another office. The tender closed under capital estimate. The bids came in under capital estimate. We designed it in 2 of our offices in Toronto and Ottawa. So we had 5 disciplines working in 3D. The exception was instrumentation and control. We've struggled a little bit to try to bring in the smart P&IDs and the use of plant-based P&ID, or smart plant P&ID, or open plant P&ID, and there's all these options now, so the Toronto office has actually struggled on narrowing down which option to pursue, and thus which one to train on. So they generated most of their P&IDs in 2D. Everybody else was in 3D, including electrical and the lighting and some integrations between electrical and architecture. The BIM was designed, carried out throughout the course of design and continued through construction, where addenda changes weren't actually incorporated within the model itself. So we actually generated RFQs where we actually took copies of our BIM model, created the RFQ. When the RFQ was accepted into a change order, integrated those changes back into the BIM itself. So we were able to actually have an as-built BIM at the end of the project. Visualizations were key, and animations. The client was just enthralled by the fact that he could see this project from the very beginning to the very end, from schematics to construction. And I like those 2 images that just flew on, because it actually shows that what we were working on versus what was built is pretty much 95% identical. We brought in renderings such as this one to the building code officials to show them exactly what we were doing, to get rid of their confusion, because they were having troubles reading what the plans actually said. Media presentations, Siege to Hill internal presentations, presentations like this. We've all reused all of the renderings that have come out of this project. And we're very proud of them too. Schematic design. The critical component here, the client sat down and said, okay, this thing has to have this membrane filtration process. It will be the largest in the world, using, I don't know who's familiar with the process, but Xenon is the manufacturer, and there's 2 types of membrane. There's membrane filters versus compressed membrane tubes. We're using the filters on this project. There was a certain amount of filters that had to be. We needed a gantry crane to get the filters in and out, and there were a lot of requirements to actually make the membrane system work. And then the client said, it's got to look beautiful. It's got to be architectural. I want this to be a masterpiece, a showpiece, and a touristic piece for the region of Peel to bring in clients from the rest of the province of Ontario. So all of a sudden, I was happy. This was incredible as architect, because Siege to Hill in the Water Business Group, being an architect, you know, we sit there listening while the process has to work. And that's true. I could never, ever deny the fact that if the process doesn't work, the project fails. If the water can't get cleaned, if the water capacity can't be met, there's no point to have the project. But to have a client look at us and say, you've got to do all that, plus have an architectural masterpiece, that was great. First time. And now it gave us a talking point now, so we can start to do this more. It's BIM and plant. The first, when I was working with Jack to title this presentation, I wanted to call it the war between BIM and plant, or the BIM plant collision. but we settled for what we did here. But it's essentially that. Where does plant stop and BIM start, and how do the two interact with each other? Throughout the latter phases, design development and contract document production, BIM continued. Plans and sections were created directly from the model through the extraction process. We had our deliverables, we met our contractual requirements, the images just kept coming. We needed to visualize this project. Through tender, any addenda that were generated through the bid process, the tender phase, were incorporated into the model, and the model was maintained throughout the course of construction. Model reviews set up on the site to actually walk the contractor through the process and the architecture. So this is the gist of the process. This was the essential component. And you see, this is just a cutaway. These are the membrane filtration tanks. Each one of those are membrane filters that are lowered into the tanks. 7 foot 11 inches wide by 1 foot 11 inches deep. Those are the exact dimensions. If you made your tank 8 feet wide, inner to inner, those filters would not fit in properly. So there were some specific requirements like that, which blew us away as architects. Like, where did you get 7 foot 11? But that's what they used. The gantry crane was the critical component to actually move these filters into place, to drop them down to the lower level, and then we'd have to get them out. So there was a fundamental issue of how do you get them out? How do you clean the filters? How do you reassemble them and put them back into place? Water comes through a main underneath this pipe gallery, gets pumped into the filter, gets sucked out of the filter, and goes on to the next treatment process. The finish of this floor, it's got the textured look because we put terrazzo on this pump gallery floor. So the client said this is where he wants the people to come and look. So normally in a treatment plant, in a pipe gallery, it's hopefully a nice concrete finish, sometimes not even that. Here we actually developed terrazzo details where the terrazzo can go up and around the pipe bases, the pump bases, how much of the pumps could be submersed in a terrazzo finish versus not, how to make the terrazzo work where the pipes went in the ground. There was some unique detailing that I've never done as architect prior to this to figure out how terrazzo and pipes interact with each other. It was really interesting. This is a section through the entire building. So to finish off the process, we've got 2 membrane tank trains. Once the water gets down, it's pumped up into this area here, which is the biological activated carbon treatment tanks. And I'm not going to pretend to know exactly what that does to the water, but it just makes it better treated. So that's why I'm an architect. So I just know it's out here. Then over here we have a chemical room and then an ozone room behind it where the water goes through its final treatment process before going out to the other side where it's in a holding tank to get to the reservoir. And you can see there's a lot of complexity in this. The section complexity is unique. And architecturally, this pump room was the main focus as well as the control room itself. So we had this curved glazing that was curved one way and curved the other way, and I'll show you a slide of that. And that's the prime focal point for the controllers to sit and operate the plant, but also for the tours to actually walk through. And the colors were very specific as well. The coral of the roof and the precast coloring is also has that pinkish hue because it's supposed to reflect a lot of the surrounding buildings. The existing treatment plant utilized that color, and there's a wastewater treatment plant close by that has that color. And some historical buildings near the Mississauga waterfront carried that same kind of color, so they wanted to import that into this project. I love this slide because when we were developing this project, this pipe gallery was just a series of crazy pipes everywhere. But architecturally, we had to sit down and say, well, you know what? We need to get to that door, and we need to walk through this gallery. We need to actually have access and egress. It has to be. We have to satisfy building codes. We have to satisfy the appeal and everything. So we had to actually devise a way to make the process work to actually give us the pipes actually acted as a canopy for our access and egress, which was a really unique situation. We couldn't bury the pipes because there were a whole bunch of cross pipes going underneath. So we had to had to revise the process to meet the architectural requirement. And then vice versa, the actual coloring of the pipes themselves, this was a suggestive rendering. They ended it with blue. But the client wanted to know, how are we going to what's the architectural look of the pipe? And that's a question that a process engineer prior to this project has never been asked, right? But it's part of the space, it's an architectural feature. You see at the top, we've got acoustical panels, we have treatment to all of the structure, what's the underside of the roof decking gonna look like, and what's the pipe gonna look like? Because it's there, it's part. What color will those pumps be? How will they all fit into the overall architectural scheme? So we had to test how to accentuate pieces of the process to actually reflect the overall look of the building. This is another image. We're standing from the opposite platform. So when tourists come in, they can walk around the entire complex and end up back where we are, having a continual view throughout the gallery and throughout the other pieces of the gallery. I've never seen more glazing in a water treatment plant, but it was a requirement. We wanted lights to get in from the clear stories down through the windows into the lowest depths of the treatment plant because it is a people space, it's a tourist space. Normally these plants are pegged as unoccupied by building code. Maybe one person might occupy it over the course of a month, but this was a completely different concept. So when we started looking at, well, what was the benefits of some of the stuff we did? These hidden line diagrams, quickly right away, image of the model, send it to the client, give them a concept, so sketches of what the interior finish of the control room might look like and what you're seeing through the control room. These were schematic design sketches that were pulled out of our schematic design model. So at 30%, we were able to quickly generate views like this. You could see that the process had just started getting some pumps in, the structural had put the bases in, but we really didn't have an idea of what the pipes were doing or what was happening, but we could give the client an idea of what the space would look like. And then the question was, okay, well, what is it actually going to look like? So during construction, we had some RFIs on the color of the pipes. So they didn't like the green, we wanted to try the blue, and then some of the routing of the pipes as well. So they caught some interferences on site. We caught most of the interferences in the model. But when we were able to combine RFI responses, so they said, what's the color going to be? Can we change this routing? Can we do this? We did up this quick mini BIM on the side, applied all of the answers in one view, one diagram, whatever the case is, sent it back to them, got the approval, incorporated the BIMs back into the working model. We were able to do some isolated diagrams and analyses. So again here, this is the membrane tank, this is the gantry crane, and the permeate pumps sends the water in, sucks the water out. That's the main process. We were able to isolate it very early on. This is a schematic design model, 30%, to actually see how will one train of this system work. And then we were able to say, once we've narrowed down how it works, let's work out the particulars. And again, this example here, there was particulars of the final color of the piping as well, and then you could see the implementation of how it looks on site. So to me as an architect, I think this looks beautiful, and it's really odd to be able to say that to a pipe gallery, but there was so much effort that was put into the coordination of disciplines, the use of BIM, and the use of plants. So all the Bentley building, the plant-based products were just talking to each other in such a beautiful unison on this project. So then we start, okay, we've proven BIM in Toronto, so we're going to start sucking quantities out of this model. So by default, we've got a setup, we've got a company standard data set that has predefined parts and families that lets us catalog any components placed by the Bentley building products on part and family by material. So we can get the total concrete by volume, surface area, whatever we need, and we can break it down to beams, slabs, columns, floors, elevated slab, whatever we need as defined by our parts. And then we will take it a step further. By use of our plant space, of Bentley's plant space products and our flow stream designations, we can now, in this database tool that we've developed, we can suck out all the lengths of the piping from the plant space database and get summaries based on flow stream. So we could see, for the membrane intake pipes, how much length of pipe do we have, and specific to what diameter that pipe is, or what material finish that is, or in this project, all the blue pipe. We could find out how much blue pipe there was versus red pipe versus green pipe, because it was a tag attribute that we added to the pipe itself within plant space. So we were able to say for a specific flow stream it will carry a specific color, and then we were able to get quantities and lengths based on those two criteria. And the last comment, actually, before I go, 95 to 98% accuracy between our quantities database and the actual manual takeoff. So this was 2003. We've proven 3D. We've sort of proven BIM. The cost estimator said, I can't trust that. He said, that's fine. Don't trust it. So go off and do your thing. So they went and did their thing, and we were that close. So that made me very happy as the BIM leader. The code officials proved to be very interesting. So we submit this thing for tender at the same time we submitted it for building permit, and the first comment back was, you need to sprinkler the building. And we sat there saying, how can we have to sprinkler a water treatment plant? That's fundamentally strange, but because the thing can't burn, it's holding water. But we said, all right, let's try to understand why you think we need to sprinkler the building. And when they were reviewing our drawings, they were counting all of this space as occupiable space. So they said that adds to your square footage, and thus you need to be sprinklered, or else you have to make the building smaller. When we brought in this image for them and showed them that of everything you're seeing in this image, that's the only occupiable space. The rest is all submerged tankage, and then the rest of the building was on the other side. And they said, oh, that makes sense. We don't need sprinklers, we meet building code, we got our permit. So a picture does speak 1,000 words, and as much as I love drawings, I think drawings are horrible, and this is the way of the future. And here's a pretty good example of that. This is near the ozone area in the chemical room, and I can't read that drawing, but that's a construction drawing that's extracted from the model. All the data in that drawing is 100% accurate. Extraction cleaned up if it didn't show things the right way, but it still makes no sense. Whereas this actually speaks to what's happening on the project. So every time we had presentations, every time we had value engineering reviews, code reviews, client reviews, whatever the case was, we had this and our arsenal of images, because every time there was a question, the answer was in the image. Okay, I'm going to speed through. I'm going too slow. Design review. Critical part of these projects on a weekly basis, we sit down all of the design leads. So we've got an interesting structure when we do project. We have a project manager, a design manager, engineers and architects, and CAD technicians. And then for every engineer and architect has their own quality control reviewer. So there's quite a few levels of activity within the project. We suck them all into a room on a weekly basis and drive them through the model. Whether we use Navigator or CAD View or Navisworks, it doesn't matter what it is. The point is, every discipline, live, drive through, here are the issues, address them right now at the table so that our guys can go off and actually do meaningful work. When we find fundamental issues that are contrary to the four-phase design, we force them to make the answers, because we can't afford to find things late in the game, have to make drastic changes, and just fail when it comes to delivery. This is one of my sections, and I look at this with pride because I did it, but I still think it's horrible because it's just a piece of paper. This is the same section in the 3D view. It tells a lot more to me, and I'm sure it does to everybody. You get a real sense that, the idea of how many platforms there are, the control room and a mechanical platform above it, the ability to see through from the gallery up to the top, and the idea of the clear story. It's all there and represented. It's all here too, but it just doesn't say the same thing for me. So what this project taught us, and we use this slide for a lot of internal discussions, when you have a model, when you have BIM, BIM can be anything and everything, or BIM can be absolutely the smallest of things. You've got to cater it to your project. BIM can do everything, all of that stuff BIM can do, and more. We've seen presentations today of what other firms are doing. On a specific project, you can only do so much, and what I always say is, if you don't know what you need to do, then you will fail. So when specific for water treatment projects, we always get the question of, are we going to do smart PNIDs? Are we going to make the PNIDs talk to the plan space model, and how will all that work with BIM? And that's a huge question. It falls on my lap all the time. And I want very clear discussions with project managers, with client owner operators. What do you guys need to see from the data? How do you define your PNIDs? How do you tag your elements? How should we do that in our plan space model? How should those talk? And once we get those answers, then BIM all of a sudden becomes a little easier, because it's the path forward is easy to implement. I'm just going to close with this video, and if there are any questions, I got 5 minutes though. So this video, we generated this for the American Waterworks Association, AWWA, conference. We did a presentation, and they just wanted to see an overview of what we've done. And we used this for code review meetings as well after that. So this is showing how the project is broken up. You've got the tankage, the occupiable space, an external gated area for the ozone tank, for an oxygen tank, which is used for the ozone, the chemical room, the ozone room, biological activated carbon tanks. We're going to go in right now to the membrane room, past the electrical room and corridor. We're in one of the membrane trains. I believe each train, I think we had 8 trains, eight units per side. And then we'll end in the pump room, which the city now uses as its main tourist attraction for the water treatment plant. And in the course of the next 3 years, we're going to be working on Lakeview CapEx 2. So basically, we're going to do another one of these in another majorly constrained area of the site, and it's even more constrained than this, so I look forward to seeing how that design shakes up. And thank you, everyone, for your attention. Questions?